Solving one-step equations. The first thing we need to talk about before we start solving equations is inverse operations. The basic operations in math are addition, subtraction, multiplication, and division. Inverse operations are going to be opposites or operations that undo each other. So talking about the four basic operations, addition is the inverse of subtraction. And this relationship works both ways. So addition is the opposite of subtraction, and subtraction is the opposite of addition. They both undo the other. And the other set of inverse operations would be multiplication and division. Again, they're going to undo each other. Multiplying by 3 is the opposite of dividing by 3. Solving equations. When we are asked to solve an equation, what is our goal? So an example, what would you do if you were asked to solve x minus 3 equals 5? What do you want to do to solve this equation? And the answer is, to solve an equation, our goal is to isolate the variable. Isolate means to get it alone on one side. To get the variable alone, we have to undo what is happening to the variable. In the last example, we had x minus 3 equals 5. What is being done to the variable? Really quickly, I'm going to stop and remind you that a variable is a letter or symbol that is representing a number. So we have x as the variable in this equation. X is one of the most commonly used variables, but it could be any letter, and it could also include some symbols for a variable. So if you ask yourself what is being done to x in x minus 3 equals 5, right now we are subtracting 3. Now you're going to ask yourself, what is the opposite of subtracting 3? The opposite of subtracting 3 is adding 3. So to solve the equation x minus 3 equals 5, I'm actually going to need to undo subtracting 3 from x, which means I need to add 3. Now when we're talking about an equation, we have an equal sign, which means that both sides are the same. If we add 3 to one side and not the other, that equal sign no longer applies. It's no longer true. So whatever I do to one side of an equation, I have to also do to the other side of the equation. So if I'm adding 3 to the left side of the equal sign, I also need to add 3 to the right side of the equal sign. Well, negative 3 plus 3 is going to cancel out, so on the left I'm only left with x, and on the right side I need to do 5 plus 3, which is 8. Now I did not type this in to this presentation, but what you can do when you're solving an equation, and what you should do when you're solving an equation, is go ahead and check your answer. To check your answer, what you're going to do is, we solved and we got x equals 8. You're going to take that 8 and you're going to plug it back in, or substitute it for x in the original. So how I would do that is, instead of x minus 3 equals 5, I would plug in 8 for x and say 8 minus 3 equals 5. And ask yourself, is 8 minus 3 equal to 5? In this case, that is true, so I've checked my answer and I know that it is correct. If you got something weird and you, let's say you solved and you got 6, and 6, then your statement would be 6 minus 3 equals 5. Well, 6 minus 3 does not equal 5, so you know you've made a mistake somewhere and you need to go back and check and make sure that you've you've solved the equation correctly. Let's try some more. If we look at the first example, we have p minus 1 equals negative 12. In this case, my variable is p. I'm subtracting 1 right now. The opposite of subtracting 1 from p would be adding 1. Remember, whatever you do to one side, you have to do to the other. My negative 1 plus 1 is going to cancel out. And on the left side, I'm going to be left with P equals, and negative 12 plus 1 is negative 11. Again, you should check your answer. It would be negative 11 minus 1 equals negative 12, and that is correct. My next example, moving down, is A plus 9 equals 45. My variable is A, and right now I am adding 9 to A. The opposite or inverse of adding 9 would be to subtract 9. Whatever we do to one side, we have to do to the other. My 9s are going to cancel out on the left, so I'm going to be left with A equals 45 minus 9 is 36. Again, you could plug it back in. 36 plus 9 equals 45 is a true statement, so I do know I have the correct answer. The next example is negative 37 equals y minus 2. Notice this is a little bit different because now my variable is on the right side of my equation. The last two that we've solved, the variable has been on the left. That's okay. We're still going to ask ourselves, what is happening to y? Right now I'm subtracting 2 from y, so the opposite of that would be to add 2. Just like in the previous examples, I'm going to do that to both sides. So I'm going to add 2 to the right and to the left. My negative 2 and my 2 cancel out on the right side of the equation, and negative 37 plus 2 is negative 35 equals y. You can go ahead and plug it back in just like you can do in the other equations, and you're left with negative 37 equals negative 35 minus 2, and that statement is correct. In the last example on this slide, we have b minus negative 2 equals negative 2. Hopefully, since we've already talked about our integer rules, you're noticing something that is a little bit special about this problem, because right in the middle we have b minus a negative 2. So I'm subtracting a negative, which is the same thing as adding a positive. So before I solve that problem, I'm going to go ahead and rewrite the equation as b plus 2 equals negative 2. Now I can notice that I'm adding 2 to my variable b. The opposite of adding 2 is subtracting 2. Whatever I do to one side, I need to do to the other. So I'm left with b equals negative 4. Not a word problem. We are going to talk about word problems and writing equations from word problems. So the first example of this says your aunt deposited $450 into her bank account. If you think about depositing money, what is that going to do to the bank account? That's going to make it increase, or you're adding money to the amount that's in the bank. The new balance is $512. What was the original balance? So right now I know that I've added $450. I know that the new balance, or the total, is $512. And I do not know the original balance. That's what I'm trying to find. So what I'm going to do is I'm going to assign a variable to the original balance. When you ask yourself what's happened to that, I've added $450 to it. And then I know that the new total is $512. So in the equation, x is representing the original balance. $450 was deposited. That's why I'm adding. And I know that the new balance is $512, so it's equal to $512. Well, what are you doing to your variable in this equation? Right now I'm adding $450. The opposite of adding $450 is to subtract $450. And when I do that, I am left with $62 as the original balance. And another word problem, it says between 7:30 a.m. and 8 a.m., the number of students in school increased by 73. Increased means it was added to. There were 152 students in the school at 8 a.m. How many students were there at 7:30? So I do not know how many students were there at 7:30. That's what my variable is going to represent. I know that the number that was there at 7:30 increased by 73. So I'm going to add 73 to that. And I know that at 8 o'clock there were 152 students. So my equation is x plus 37 equals 152. Right now I'm adding 73. I'm sorry, I think I said 37. It's 73. Right now I'm adding 73 to my variable. The opposite of that is to subtract 73. And when I do that to both sides, I'm left with 79 students there at 7:30. Let's try some. In this case, the last examples that we've talked about were addition and subtraction equations. Now I'm going to have multiplication and division equations. They're going to be similar, but now the inverse operations that we're going to use need to go with multiplication and division. So if you read the first example, we have x divided by 5 equals 2. The opposite of dividing x by 5 would be to multiply by 5 on both sides of the equation. Well, my 5's are going to cancel out on the left side, so I'm going to be left with x equals, and 2 times 5 is 10. Moving down, I have 22 equals negative 11k. My variable in this side is on the right side of the equation. That's okay. I'm still asking myself, what am I doing to, in this case, k? The answer is I'm multiplying it by negative 11. The opposite of multiplying by negative 11 is to divide by negative 11. When I do that, my negative 11's cancel each other out on the right side, leaving me with just k. And on the left, a positive 22 divided by a negative 11 leaves you with negative 2 equals k. The next example, we have negative 2 equals m divided by 16. Right now, my variable m is being divided by 16. The opposite of dividing by 16 is to multiply by 16. My 16's are going to cancel out on the right side of my equation. 16 times a negative 2 on the left side leaves me with a negative 32 equals m. Again, all of these problems, you should be going ahead and plugging them back in and making sure that they work. So in this case, what I would do is I would say negative 2 equals negative 32 divided by 16. Well, negative 32 divided by 16 is negative 2, so I've checked my answer and I know that it is correct. The last example on this page, we have negative 40 equals negative 5 times p. The opposite of multiplying p times negative 5 is to divide by negative 5, and whatever I do to one side, I need to do to the other. On the right side of the equation, negative 5 divided by negative 5 is going to cancel and leave me with just p. And negative 40 divided by negative 5 on the left side of the equation leaves me with a positive 8. To check this equation, I would have negative 40 equals negative 5 times 8. And negative 5 times 8 does equal negative 40, so my answer is correct. The next example says, how many boxes of envelopes can you buy with $12 if one box costs $3? So I know that I have $12 to spend, and I know that one box of envelopes costs $3. I want to know how many I can buy. What you're going to do when you're buying the same thing repeatedly is you would take the price, which is in this case $3, times how many you can buy. That's the question, so that's what my variable would be. And it's going to equal the total cost. I know that my total cost can be $12 in this instance. So the equation that I'm going to write is 3x equals 12. 3 is the cost of the boxes. X would represent the number of boxes that I can buy. And 12 is the total cost in this case that I have to spend. To solve for x, I need to divide by 3 on both sides. My 3's are going to cancel out on the left side of my equation, leaving me with x equals 12 divided by 3, which is 4. So my answer would be that I could buy 4 boxes of envelopes with the $12. The last example says, at a restaurant, Mike and his 3 friends decided to divide the bill evenly. If each person paid $13, then what was the total bill? My variable is going to represent the total bill. What happened to the total bill is that Mike and his 3 friends decided to divide it evenly. It gives you a big keyword there, divide. So how many people divided the bill evenly? This is a little bit of a trick because it's Mike and his 3 friends. So how many people were there total? There were 4 people total, including Mike. So the original bill, which we're just going to call X, was divided by 4, and each person paid $13. So my equation is X divided by 4 equals 13. To solve for X, I need to do the opposite of dividing by 14, which is to by 4, which is to multiply by 4 on both sides. My 4's cancel out on the left, so I'm left with just X equals 13 times 4 is 52. So the total bill was $52. The last example says Cindy and her friend found money and split it equally. If both girls got $19, how much money did they find? I do not know how much they found. I do know that Cindy and her friend, so 2 people, split it equally. So when I'm talking about splitting, I'm talking about dividing it. And I know that each girl got $19. So my equation would be X, the total amount of money, divided by 2, which is how many people split it, equals 19. Right now I'm dividing X by 2. The opposite of dividing by 2 is multiplying by 2 on both sides. So my answer for X would be 19 times 2 is 38. So the girls found $38 total.